Welcome to the Curious Developer. I'm Jesper Pedersen from KDAB, and today I have with me nobody less than Nicolai,
Nico, just say Nico.
Nico, who you all, I'm sure, know already. He's the best-selling author of a number of C++ books, and let me just read out for you, for those of you that might not be all up to speed here. The C++ Standard Library, a tutorial and reference. C++ Templates, the complete guide, and I have it at home. I made it through page 100, and still a lot to learn in there. C++ 17, the complete guide. C++ 20, the complete guide. And finally, C++ Move Semantics, the complete guide. Very hardcore topics, I'd say. So I'm just wondering, let's just start out with that. Did it even start before all these C++ books? Did you write Corva, the complete guide? That seems to be a good starting point for anybody.
Well, first of all, thank you very much. Hi, Jesper. And hi, everybody. Yeah, it all started with the C++ Standard Library, a tutorial and reference, but it was written in German. And it was not my first book. In fact, the first book was that I was a co-author of something called the X Windows System in a German book. That's very old. Only old guys will know what that is. And OSF motif. And so that's where I made my first experiences writing books. And then I switched over to C++ and wrote about C++. And the complete guide was just the name for the C++ templates book. And it turned out to me that maybe this is a nice subtitle for a series of books if I just have the idea to write about something in total, covering every aspect for beginners and for experts, which is at least what I try to do.
Let me just check my notes here. 17, 20, it's 2025 now. Where is the C++ 23, the complete guide?
Oh, it's on my laptop behind me. It's currently I write it. Yeah, it's that it takes a while until I write it, because the usual way I write books is not that I write about theory. I write about practice, how to use it in practice, and that first of all means we need compilers to support that. And then we need a little bit of experience and a little bit of bug handling and dealing and discussing about issues. And in addition, C++ 20, the complete guide, I was really exhausted when I wrote that. That was so much new stuff. So it took me a while. The first version should be available more or less at the end of 2025. And I published it step by step as an ebook, so you get all the updates for free. And I hope in about 1 year, then the complete C++ 23, the complete guide, is available.
I know what's going on here. It will be ready just for Christmas here, so.
No, it will be ready.
It's what I want under the Christmas tree this year, please.
Yeah. But 5 of them is better than 1. But no, I think that I'm looking forward to have it out at CPPCon, which is in the US, the most important conference. And so that is roughly my guideline, because there are also some other conferences around, and that seems to be a good goal. Let's see. Let's see.
So walk me through the process of writing a book. I know you're a C++ trainer, and there's no better way to learn something than to teach it to somebody else. It's like, excuse me, but why? It's like, ooh.
So it's not only but why, they also ask, what happens if I do this and that? And which are really some silly questions, but you are faced with that, and you try to give an answer. And indeed, I learn by teaching C++. And I learn both what is under interest, but even more important, what is the best way to teach these stuff. So the examples get continuously improved. The order of teaching is updated so that it fits better and better. And key of teaching is to have really a good story, good precise wording, but not enough information and not too much information, but not only a few slides that everything looks easy and that's it. So finding the right pace, the right content is really an issue. And I learn a lot from trainings. So I usually wait until I gave a couple of trainings about C++23 in this case, which started the first training at the beginning of that year. And now I have done, I think something like 10 trainings about C++23. And now I'm ready to write the stuff in a book. Yeah, I feel comfortable now.
And a nice side effect of continuously updating your training material is that if somebody comes back to your training, it's because that they want to learn the new stuff that you put in, rather than because you didn't present it well enough for the first iteration.
Oh yeah, I should teach so bad that they ask for the same training 3 times in a row. Yeah, I never had that, but there was once. I think once I had one person attending 2 or 3 times the same training. I was really confused, but no,
it's interesting though, isn't it? I mean, just there is this conception that if you just go to the training, then you'll learn. It's like, no, that's just a starting point for you to open your mind on which path to take. And I mean, we have some in-house trainings in KDAB that I've taken a couple of times, and C++11 was one of those. I took it very early on, and then I took it like in 16 or 17 when I had a bit of experience, and now I needed to fill in all of those holes that was taught to me early on, but I don't have a conceptual mental model of what we're talking about.
C++ is so complex that you cannot learn it at once. That doesn't matter how smart you are. Even the people in the C++ standard committee do not know everything about C++. Nobody does that.
Right.
And so we have this situation that whenever you have a training, when you present a topic, you should start with the general stuff, conceptual introduction. Why do we have that? And simple examples. And then you go deeper and deeper and deeper and dive deeper into the topic. And yes, indeed, the same person could see the same presentation and first time benefit most from the first third, then benefit most from the second third, and then benefit most from the last third. And still, there are open questions. So that's just C++. Nothing is easy in C++. And even if it looks easy, the moment you look into the details, you're wondering why things work and run well.
So I hope I'm not offending you if I'm indicating you are not a youngster anymore. You have been in the C++ committee, I've been told, from your presentation online for more than 25 years. How long is it exactly by now? And
depends a little bit how you count. It's probably C++. I'm involved in C++ for 30 years now. And the first C++ standard committee meeting was about 1996, I think. So this is 29 years ago.
So you were there from the very first day.
It's all my fault, at least partially. Yeah, that's it. We have 200 other people who are also responsible, and we not always agree. And no, indeed, I've seen a lot. I was in the room when the first C++ standard was published, and yeah, I thought it's a short thing, but it's a use.
So you're the best person to walk us through how does C++ evolve from somebody sitting in their cellar saying, wouldn't it be cool, until it's in my compiler?
Oh, that's a tricky question. In principle, so something to understand is C++ is community driven. So it's not that there's a company behind it. It's not that there's a chief architect behind it. Well, Jan was the founder, but he gave the control to the C++ standard committee, and that meant he gave control to the community as a whole. And so everybody who's interested can come up with something. And so sometimes it's pretty fast. So somebody has an idea, comes up with something. Oh yeah, you're right, we should do that, and that's it. And in other times, things can take 20 years to be successful or to finally be in the standard. Sometimes things come in step by step. Sometimes as a whole, it's a little bit tricky to know in ahead how long things go. And the fun part is, if it's very easy and compelling, it's fast. And if it's so complicated that only 5 people understand it, it's fast. But if it's in the middle, so if everybody can have an opinion and can have a different opinion, then it takes time. So that's one reason why, for example, STD optional took way longer than we thought, because we had in a certain area, we had different opinions how to deal with that. But on the other hand, doing something like ranges, which is way more bigger, was more or less accepted in the standard committee after 3 years of work of just a subgroup of people. But it was not that 200 people knew what's coming. It was that only 10 people knew what was coming. And so that's the difference. It always depends.
To quote Douglas Adams, time is an illusion, lunchtime double so. Only 3 years for something to get through. That sounds like an eternity. But isn't that a dual-edged sword? I mean, we get a lot of input from a lot of people, but at the same time, things take time, and the rest of the world are moving on in a faster pace. Let me just, I was talking to Jan Strostrup earlier on, and he was explaining how excited he was about profiles. And profiles didn't make it into C++ 26. Now it will be C++ 29. Hopefully.
Let's see. Hopefully.
Hopefully.
I don't know.
And then it will take a few years before it's adopted to the larger audience. That is, if you take that same time frame and go back in time, dinosaurs was roaming around the planet. That is a long time in today's world, isn't it? Or where is my misconception?
A couple of remarks on that. So the first thing is, when I was young and started with C++, I said, oh, look at these Fortran and COBOL guys. They're doing the same programming language for 30 years now. What a shame. They should do something modern. Let me do something modern. So I'm now in that situation, in the same state. So that's about life. And the other thing is, even if Bjarne wants to have profiles, there's a reason. Not everybody is excited. So, and it takes time. So there's resistance. So one is people don't like change. That's one thing. And the other thing is they have different opinions. But also it could happen that it might not be that well thought out, that it's so compelling that it's acceptable to everybody. We had that in the past. We had a proposal for initializer list, and what we standardized was to some extent probably a mistake. And we had that in other places where we found out that thinking one more couple of years about things is making things better. Concepts is a good example. Concepts should have come in C++ 11, and then it got too complicated, and it was taken out again. So before it was finally shipped, and then later on it came with a way better improvement and way better way to use it. And so yeah, everybody wants to have her own feature as soon as possible and thinks it's great. But I learned over time that this is not the case. And the third comment I would like to make is, don't forget about what standardization is about. It should standardize existing practice. And so there should be some experience, and we just want to standardize it. Now, standardization these times often is inventing something new and then saying, this is the truth, this is what everybody should do, this is how everybody should do it. And so you are about to establishing rules without any experience and then you are surprised that these rules don't work everywhere or have some pitfalls or traps. And that is also a danger. And maybe finally I should say, when we meet 3 times a year, 1 week, that means every year we meet 3 weeks. So if we have a release every 3 years, that means we have a release every 9 meetings. And that's a lot from that point of view. So there is a couple of reasons why this is so slow, and this is not always bad. This is something sometimes also good. And especially library features could be invented beside that. We are especially having the problems with language features because they need different compilers, but you can even set up experimental compilers and see how this feels like. So yes, time, everybody wants to have time, wants to have things as soon as possible. Especially if you get older, you have only a few more years to live. You want to get it done, but it's not always good.
Not there yet, neither of us.
Oh, maybe.
I remember occasionally including something experimental. Are we using that idea of putting things out experimental too little?
Here's the problem. If something is experimental, it's not taken seriously. So we have a couple of examples where we had an experimental library, we could try it out, and then when we standardized it, suddenly we cared about it and we found serious flaws. So we need more something like, that's my opinion, something like, let's put it in the standard, but let's keep the right for this new feature to update things in a backward compatible breaking way. And that is a problem, because once we have it in the standard, then it is looked at. Then it's, for example, me writing about it in my books, and by that I'm an early adapter, and I found a couple of things very earlier than others. But I don't look at that when it's experimental. It just would take me too much time. I can't do that. 200 people are standardizing C++. We have 20 different subgroups. You cannot follow everything in a head. So,
but at the same time, 20 subgroups, 200 people, in my my usage of AI, I can come to the number that's 10 people that in total would be looking really much into the details of something that might potentially have an influence on millions of C++ developers.
Yeah, that's the point. I mean, at the end, and some of the stuff we standardize, only 10 people are looking at details, and these details then are the base for the future of 4 million programmers. And then they're surprised when we find something. That's I'm not very happy with the way this works right now. You can hear that. It's when we standardized C++, when we started to do it, nobody should forget, in these times when we started with the first standard, we had no laptops, we had no internet. And that is, we came together and we had a printed out standard, we were discussing it. We had one PDP-11, a computer in the room to try out things, and so we had a very slow pace to standardize something. But that was good, because everybody could follow everything, everybody had the whole picture, and we were much more concentrated on things. And that's why the basics of the whole access of C++, which is a standard library, standard template library with containers and algorithms, was so successful. And that these times have gone. We are now coming with a big mass of things.
So just remember, kids, when you talk about C++ 11, it's 1911, obviously, with the PDP-11 or whatever the computer is called.
1911? No.
I mean, when was the first standout of C++?
1998.
Right.
Not 1911, you said.
Yeah.
We had that. We didn't have laptops in that time. Yeah, we couldn't fly to a meeting and everybody could try out code locally. We didn't have that. That's it. Yeah, you can't imagine that. That was also a time where we didn't have mobile phones. You can't imagine how this world was. It was totally crazy. And I'm pretty surprised that we still are alive.
That's a topic for another interview. Trust me.
I need a beer right now.
Let me interrupt you here, ladies and gentlemen, in the next episode, because I'm not done talking to Nico. We will talk about ranges.
It's not a problem about ranges in general. It's a problem about views, especially some views. The design of views is completely broken.
What you really need in the standard committee is subpar developers, and no, that's not an offer.
We need more ordinary programmers who are not experts.
He is very vocal about problems with the ranges, especially with the filter view. I'll discuss that in detail, so stay tuned.